Welcome back, everyone, to geometry. We want to take a look at activity 7.6, which discusses the circumference and area of a circle. So let's take a look at that. We want to consider a regular n-gon with a circumscribed circle of radius r. For a picture of that, we could think of this hexagon that's given on the previous page. So hexagon with circumscribing circle of radius r. Excellent. So we want to find formulas in terms of n and r for the apothem, the side length, the perimeter p, the ratio p over a, and the area of the n-gon. Okay, so we want to find these for, of course, the regular n-gon. Use n, the number of sides, and r, the radius of the circumscribing circle, to find formulas for the apothem, the side length, the perimeter, the ratio of perimeter over apothem, and the area of the n-gon. Okay, so we want to find those formulas. We're going to have to use some trigonometry to help us out with that. And then in order to, we take the sine or cosine of an angle. So to help us out, we need also theta in terms of r and n. Of course, r won't come into play for that. But so I'm going to help us out. We'll find theta and we'll find a, and then I'll leave it for you guys to find s, p, and a. So the side length, the perimeter, and area. For theta, we want to recognize that to complete the circle, we would have to have, let's see here, 2n of these thetas. So here on our hexagon, there's 2 of them for this 1/6 of the circle. So you would need 2 more, 2 more, 2 more, 2 more, 2 more. All right, so that gives us 2, 4, 6, 8, 10, 12 thetas for a hexagon. That's 2n of these thetas. So we would need, we have that 2 pi equals 2n of the thetas. So that would give us, let's see, divide by 2n, so 2 pi divided by 2n gives us theta, and pi over n is equal to theta. Excellent. So we can place that right here. That was pi over n. That is theta. Now we could find the length of the apothem. The length of the apothem is the height of this larger triangle, but we notice that as we've already conveniently drawn, we have a right triangle right here. So using right triangle trigonometry, we would have, let's see here, a right triangle that we could draw like this. This angle measure is theta. This side length is a, this side length is r, and this side length is 1/2 of s. So if I want to find an expression for a in terms of r and n, I can do that. So if I take, let's see here, sine of theta would be the opposite over hypotenuse. Cosine of theta would be equal to the adjacent over hypotenuse. And that would be what we need here, right? So if this is theta, this was r is the hypotenuse, a is the adjacent side length, and 1/2 s is the opposite side length. So we want to use cosine of theta to identify a. So cosine of theta is equal to the adjacent, which is a, over the hypotenuse, which is r. multiply both sides by r to get r times the cosine of theta is equal to a. Now we want a formula for a in terms of r and n, but of course we know what theta is. That's pi over n. So a is equal to r times cosine pi over n. A is equal to r times cosine pi over n. Excellent. So now what you are able to do is you're able to fill in S for the side length, P for perimeter, and A for area. Okay, I'll let you guys fill those in using the same concepts as we just did to find the length of the apothem. Once you have those formulas, you'll be able to check them using this line that's already been filled out. Okay, so we want to fill out this table. N gives this number of sides for our regular polygon, and we just want to fill in what the angle measure is, what the length of the apothem is, the length of the side, the perimeter, the ratio, and the area. Now we're not given the radius in this case, so what we actually need to do is all of these things should still be in terms of r. Okay, there should be an r for all four, or sorry, not all four, but 4 places for the A, S, P, and A, and R will be involved. So fill it out for 4 sides, 6 sides, 12 sides, and 100 sides, and then make a conjecture, right? Guess as to what that would be when we take the limit as n goes to infinity. Now I'll give you a nice hint. For some of these, they should have pi in them. So we don't see pi here. Some of these involve pi, or should involve a multiple of pi rather. In fact, there are 3 of them. Okay. So for some of these, as n goes to infinity, you would find that it goes to something with pi in it. Okay. Excellent. All right. I would encourage you to pause the video at this point and go ahead and work on that table because I'm going to fill out property 7.7 and then make one additional comment. So pause, work on the table, come back. All right. So hopefully you've taken the time to fill out that table. So for a circle of radius r, their circumference and area are given by exactly the things that you should find as n goes to infinity for the perimeter and the area. Right? As n goes to infinity, you're approaching what would be a circle, right? If the number of sides are infinite, you are approaching a circle. So the perimeter gives as n goes to infinity, the perimeter gives the formula for the circumference, which would be circumference is equal to 2 pi r, and the perimeter is equal to pi r squared. Perimeter, I don't know why I said that. Circumference is 2 pi r, area is pi r squared. All right, excellent. So it's a little bit interesting to say the area of a circle, because a circle is just a line that is created from, right? It's a line that's not straight. It's a line, it's a curve that connects back to itself. So there's actually no area to a circle, technically. But there is area to the interior of the circle. So unfortunately, this isn't the way that things are phrased. In practice, right, we really talk about the area of a circle, and we understand that it means the area of the interior of a circle. If we were to be formal about things, we can talk about the area of a disk, where a disk of radius r is the collection of points which are not only a distance of r away from the center, but also less than the distance r. Okay, So it's the collection of points which are r units or less away from the center. That would be a disk, and it would make sense to talk about the area of a disk. But we also talk about the area of a circle and understand that we are actually referring to the area of the disk or the area of the interior of the circle. Excellent. So really quickly, I'd like to share another way in which we could find the formulas for the area of a circle, or the formula. So what we do is we cut a disk into n pieces. Excellent. So if we take a disk and we cut it into n pieces, to make things look nice here at first, let's just say that there's 4. Of course, this is the radius r. N equals 4 pieces. What we could do is we could take those 4 pieces and line them up. 1 piece, 2 pieces, 3 pieces, 4 pieces. Right, so now we have 1, 2, 3, 4 pieces of our disk. And this distance here would be pi times r, and this distance here would be r. Make sense? All right. So if we were to increase the number of pieces that we cut the triangle into, so let's say we cut it into 8 pieces. So that would give us, let's see here, 1, 2, 3, 4, 5, 6, 7, 8. Add these guys. Right, we have 8 pieces there. 1, 2, 3, 4, 5, 6, 7, 8 pi pieces. And we would have this length is r, and this length is pi times r, right? It doesn't change, it stays exactly the same. But as we let n go to infinity, what happens is this thing, the bumps there become so small that it becomes smooth. And we have a rectangle, right? Approaches rectangle. And of course, the area of a rectangle is length times width. So we have r and pi r still, right? It doesn't change. Area is pi r times r, pi r squared. So the area of a rectangle gives us the area of our circle. Excellent. So that's another way that we could calculate or find the formula for the area of a circle. That's it for this video. We've got, let's see here, I think 2 more videos that we want to take a look at for some definitions and examples. And then a 3rd video that we would also like to do with a proof. The last one with proofs will probably be posted a little bit later. So for now, have a great day. I will see you guys again soon to talk more about circles and spheres.